1425 says that a 6 kilogram shell moving with velocity v naught of 12 meters per second in the I and minus 9 meters per second in J and minus 360 meters per second in K explodes at point D into 3 fragments A, B, and C of mass respectively 2, 1, and 3 kilograms. Knowing that the fragments hit the wall at the points indicated, determine the speed of each fragment immediately after the explosion. Assume that the elevation changes due to gravity may be neglected in this case. All right, so what we have for the initial velocity then is 12 meters per second, I minus 9 meters per second, J minus 360 meters per second, K. I'm going to call it Vx, Vy, and Vz. And here's the masses. Ma is 2 times the mass of B, and MP is 1 kilogram, and MC is 3 times the mass of B. And M is the total mass, which turns out to be 6 kilograms. Going to use conservation of linear momentum here. Linear momentum is going to be equal to the total mass times the velocity of the center of mass, which initially was V naught. And so we got the total mass there. That's equal to M then for total mass times V naught. And then that's got to be equal to, after the explosion, it's got to be equal to MA VA prime plus MB VB prime plus MC VC prime. Now, we're going to rewrite this right here with Vx, Vy, and Vz that we defined up here. And then that's equal to M A times VA, VA prime. And I'm going to drop the primes off here since we really don't need them for identification purposes. So we have MAVA times a unit vector in the A direction plus MBVB times a unit vector in the B direction plus MCVC times the unit vector in the C direction. Now, if you take a look at R sub A, for example, it's minus 1.5 I minus 4K meters. That's right over here. Has no J component. So if we look at a unit vector in this direction, and this R sub A is measured from right here. So there's the R sub A vector. If we take its magnitude, its vector, and divide by its magnitude, we get a unit vector. Then it looks like this. Doing the same thing for B and C, we get unit vectors that look like this. And so we go back into our expression up here. We're going to have M's in every term. I'm going to go ahead and write out this expression again, just like I have right there. But I'm going to cancel out the M's and leave a 6 and a 2 and a 1 and a 3 right there. If we form these into equations, right here looking at the I parts, you got 6Vx, the Yj part's going to 6Vy, and a 6Vz. Over here, if you start looking at the X parts for these right here, you'll find that lambda sub A has a minus 1.5 over the square root of 18.25. There's that term right there, and then the 2 right here. Lambda sub B has a 4 over 6 right there, which is a 2/3, and its mass is 1, so we're going to end up with a 2/3 right there. And then looking at lambda C, there's no I part in there, so it's 0 times V sub C. And you do similar things for the other equations, and you end up with 3 equations with 3 unknowns, and simultaneous solutions will give you V sub A is 647 meters per second, V sub B is 789 meters per second, and V sub C is 176.2 meters per second. And their directions, it said determine the speed of each fragment, so we're not actually after directions, but their directions are given by these unit vectors that we had up here.